Welcome to episode 6 of my Splunk SIEM series. In my previous videos, I demonstrate how the Splunk can be used to detect attacks such as the brute force DDoS and SQL injection, web directory enumeration, and suspicious sudo activity. But from this episode, I'm changing the way I approach this series. Instead of starting with an attack and then searching for the logs, we are going to work more like a SOC analysis. We receive suspicious activity, investigate the available telemetry, correlate the evidence, and demonstrate whether the evidence should be escalated. In today's scenario, we are working for the fictional company called Apex Retail Limited. One of our employees, Alice Wilson, successfully authenticated to the company's employee portal from London. Only a few minutes later, the same account generated another successful authentication from Sydney, Australia. Obviously, traveling from London to Australia within a few minutes is physically impossible. But does that automatically mean Alice's account has been compromised? Let's investigate this activity using the Splunk. Okay, this is our Ubuntu. Before starting the investigation, let me quickly explain my lab environment. I have an Ubuntu service acting as an Apex Retail web server and victim system. The Ubuntu service is also running a Splunk Universal Forwarder, which send authentication logs to my Splunk server. I have a Kali Linux machine here. This is the Kali Linux machine, and I used to generate the simulate the authentication activity. And finally, I have a Splunk Enterprise here, guys. Whether we'll investigate the incident. This is the control lab environment, and all authentication activity in this video is simulated for the educational purposes. Okay, let's start. We're going to Apex authentication. We can have that pie. Look at that, guys. And on my Ubuntu server, I create a simple Flask authentication application for the fictional app Apex Retail Employee Portal. The purpose of this application is not to build a production authentication system. Its purpose to generate structured authentication telemetry that we can investigate in the Splunk. For example, if I want to mention that the user, look at this user is Alice Wilson. And for this scenario, Alice Wilson is our test employee. And when an authentication attempt occur, the application record the timestamp, event type, application name, username, source IP address, and authentication states. These fields will later allow us to investigate the activity in the Splunk. Okay, the authentication events are written to this log file. My Splunk Universal Forwarder is monitoring this file and forward the events to the Splunk Enterprise, obviously. Sudo cat Splunk Forwarder etc system local and input.configure. And inside my Splunk Forwarder configuration, I'm monitoring the authentication log and assigning the custom type, source type, this authentication. Where is it? Apex Authentication. Using a dedicated source type make the authentication telemetry easier to identify and investigate it. Okay, let's open the Splunk and let's show you something on the lookups. I already add this file, and because this is a control lab, I'm not using the real public user IP address. Instead I've create a custom Splunk lookup table contains simulate IP to location mapping. This gives me a predictable and repeatable telemetry for the investigation. Okay, as you can see, uh, we using the input lookup command, I can inspect the content of my lookup table. The first simulate source IP represents London in the United Kingdom, and second simulate source IP represents Sydney in the Australia. These IP addresses are used only as a control lab identifies, and the latitude and longitude field will also allow us to visualize the authentication location later in the Splunk. And I need to clarify that because I don't pretend these IPs naturally locate to the London and Sydney actually. And let's start it with the generate the first authentication event. In our scenario, Alice is normally based in the London and successfully authenticate to the Apex uh, employee portal. Okay, let's zoom in. Okay, we want to curl this to simulate that Alice Wilson with this password wanna actually log in from the London with this IP to connect this IP with this port. Just happened. Let's enter that, and as you can see, authentication is successful. And for this control lab, I'm using the X forward for a header to generate the simulate source IP telemetry. In a production environment, this header should only be trusted when it's inserted or centralized by trusted infrastructure such as a reverse proxy or load balancer. And let's uh, imagine that only a few minutes later another successful authentication occurred for exactly the same account, but this time the source is associated with Sydney, Australia, with a different IP and location, but destination is the same, account and password is the same. Look at what just happened. Someone from the Sydney with this IP can successfully log in. Okay. From the application perspective, both events use a valid credential. Now let's move the Splunk and investigate this activity without assuming that the account is already compromised. As a second analyst, I wanted to start with the board search. I don't want to immediately jump to the conclusion. Main source Apex authentication, and this is the whole raw data which happened in a different times because I did it few times. And let's filter that state counts by username status. Okay, Alison Wilson can successfully log in 11 times, which is somehow suspicious. But we need to make sure 100%. We can see successful authentication event with the Alice Wilson, and now we need to be more specific. Username status. Okay, and now I'm filtering for successful authentication events associated with Alice. Notice that I'm focusing on successful logins. Failed authentication events can indicate brute force activities, but in the scenario, our concern is whether valid credentials are being used by an authorized person. States count by SRC IP. What does mean? Uh, Actually, I'm grouping the successful authentication by the source of the IP address. Okay, we can see two different source IP. This is the local IP. It doesn't matter what's that, and this is something noise. This two names is noise, just noise. It doesn't matter what is this. We just see two different source IP associated with the same user account. However, multiply IP address alone are not enough to confirm a malicious activity. A user could change network, use mobile data, connect through a VPN, or access the application from another device. We need more context. We use lookup and in the output we need country Latin long. Then we show it on a table and username src IP city country and status. Oh, sorry. I don't know why. Okay, look at that. I'm now using the Splunk lookup command. Splunk Splunk take the SRP SRCIP field from the each authentication events and compares it against SRCIP column in my Apex IP location lookup. When a match is found, Splunk enrich the events with the city, country, latitude, and longitude. And now the activity become much more interesting. One authentication is associated with London in the United Kingdom. The other authentication is associated with the Sydney, Australia. The same account has successfully authenticated from two geographically distant locations. But geographically alone is still not enough. The next question is time. I'm gonna sorting uh, the events to reconstruct Alice authentication with a timeline. So we add a sort which I accept, which I accept to know that. Then we keep all things. Okay, and we add a time, sort it with a 0, and here we can see the London authentication. And only a few minutes later, or 1 hour later, the same account successfully authenticate from the Sydney. This combination of the identify geographically and time create a potential impossible travel conditions. Now let's make it more interesting. Because our lookup also contains a latitude and longitude value, we can visual the authentication's location. Here we can see authentication activity associated with the London as city. Let's do that. Okay, use geo state lat field is lat. This is lat, and heartbeat is low. Count by username. Okay, and we open chart, choose this map, and look at that. So three on the London and four times on the here in the Sydney. But a visualization is not evidence of account compromise itself. We still need to analyze the relationship between the events. At this stage, we have identified 3 important indicators. The same user account successfully authenticate a few times. The authenticators are associated with the 2 geographical distance location, and the time difference between the events makes physically travel unrealistic. This behavior is commonly described as impossible travel. However, an impossible travel alert is not automatically a confirmed security incident. VPN service, corporate proxies, cloud gateway, and inaccurate location data can all generate similar behavior. In the real SOC environment, I would now review the identify provide logs, MFA events, device information, VPN telemetry, and the user normal authenticate baseline. I would also review what Alice account did immediately after the suspicious account authentication. For example, did the account access sensitive data? Did it change security setting? Did it create a new session, or did it perform activity that is unusual for Alice? And you can see simple in the incident summary, because based on the telemetry available in this tab, my incident assessment is the following. The incident type is suspicious authentication activity with a potential impossible travel condition. This affect account this affected account is Alice Wilson. The affected application is Apex employee portal. Both authentication attempts were successful. The observed location are London and Sydney. The time between the authentication events is physically inconsistent with the normal travel. At this stage, I would classify the events as suspicious and escalate is a further investigation. I would not immediately label this is a confirmed account compromise because additional identify and device telemetry is required. I strongly recommend this wording. It sounds more like a real analyst than saying Alice was hacker. If Alice confirms that she did not perform the Sydney authentication, I would treat the account as a potentially compromised. The immediate response action would include revoking active session, forcing a credential reset, reviewing MFA activity, temporarily restricting the account is required, and investigation of activity performed after the suspicious login. I would also hunt for the suspicious source indicator across other user accounts to determine whether this is an isolated event or part of a wider credential attack. Okay, SRC IP 198.1.100.25. And values as users by source IP. For example, I can search for the suspicious source IP across the authentication telemetry. If the same source is associated with a multiple employee account, the scope of the investigation may need to be expanded. This is a good threat hunting moment in your job. In this episode, we investigate potential impossible travel authentication incident using Splunk. We started with the raw authentication telemetry and identify multiple successful login for the same account. We then use a custom Splunk lookup to enrich the source IP field with a controlled geographical context. After reconstructing the authentication timeline, we identify successful login from the London and Sydney with an unrealistic travel period. We also visualize the authentication location and discuss why impossible travel should be treated as in an investigation signal rather than automatic proof of the account compromise. The key lesson from this investigation is that detection is only the beginning. A SOC analyst must validate the evidence, understand the available temporary, and consider possible false positive and demonstrate appropriate response. In the next episode of Splunk SIEM series, we will investigate another security incident inside the Apex retail environment. If you find this investigation useful, subscribe to the channel and follow the series. Thanks for watching, and I'll see you in the next investigation.